In this video, we're going to discuss exterior angles. This is Unit 6, Activity 3 for the Grade 9 Reach Ahead Math course. Let's again start with triangles. It's a good idea to kind of label our vertices or our angles. So let's call this triangle ABC. And we can label the three sides, 50 degrees. I don't know, what does that look like? Maybe 80 degrees. Let's say 85. Angle C here is the missing interior angle. What is an exterior angle? Well, an exterior angle, if I continue the side lengths, so for example, if I continue that line segment AC, the exterior angle will be that angle created on the outside. So the exterior angle is always supplementary. It creates a straight line with the interior angle it's next to. It actually, interestingly, doesn't matter which line I continue. We're going to have the same angle. So I could continue the line segment AC. I also could have, and I'll just kind of draw this quickly, I could have had that same triangle. I could have continued BC. And this angle here is actually going to be the same. It doesn't matter which way I continue the angle. As long as it's supplementary with the adjacent interior angle, we call that the exterior angle. Let's talk a little bit about how we name angles. I've now got two angles at vertex C. So if I want to talk about the interior angle, which is on the inside here, I'll put a little dot there, I would have to call that interior angle, we could call it ACB. So it's created by the rays AC and CB. The vertex is the middle of the three letters. So that's my interior angle. If I call this point D there, then angle DCB, or I could also call it BCD, is my exterior angle. And again, the vertex has to be in the middle. So you got to be careful sometimes we label angles if I've got two angles surrounding the same vertex. What is my exterior angle DCB here? Well, I know it creates a straight line. So 180 degrees will be the sum of these two angles, the interior and the exterior. So we know the interior is whatever is left over from 180. And the exterior is just going to be 180 minus whatever that is. So if I add those two up, 50 plus 185 is 135. 180 take away 135 is 45. So that's my interior angle. And then I would just do 180 minus that to find this exterior angle here. So that would be 135 degrees. And what you can probably notice, a nice shortcut to see, is that this exterior angle of a triangle is always going to be the sum of the other two. So angles A and B sum to 135, and that's going to be the same as the corresponding exterior angle, the remaining exterior angle. So that's true with any triangle. Let's look at kind of a different shape. So if maybe I've got 100 degrees and 30 degrees, then I don't even need to worry about calculating the interior angle. If I want to know this exterior angle here, it's just going to be the sum 100 plus 30, so that would be 130 degrees. So that would be the exterior angle in triangles. And what we're going to notice, so I do know that that third one is 50 degrees. I either know it because of my supplementary angle theorem or because they sum to 180. And I can calculate the other exterior angle. So every triangle has 3 interior and 3 exterior. So this angle here will be the sum 100 plus 50 is 150. And then this last exterior angle would be 50 plus 30 is 80. So if I sum my 3 exterior angles, I get 130 plus 150 plus 80. So the sum of the exterior angles of a triangle equals 360. Okay, sounds good. Let's move on to quadrilaterals. Probably should be using a ruler, but I think we get the idea. We'll do this one really quickly. Let's look at a regular quadrilateral, which we call a square. If I extend the angles, then I'll get my 4 exterior angles here. So that's, let me use a different colored pen. So these are my 4 exterior angles in a square. You can tell pretty quickly they're each 90. So I've got 90 times 4 of them. Okay, interesting. The exterior angles of a square also equal 360 degrees. And it turned out that any shape, the exterior angles add to 360. The way I like to think about this is the exterior angles, if you're a car driving around a shape, the exterior angle is how much you have to rotate or turn your wheels to then drive the next side. And since you always are going to end up back at the start, no matter what shape it is, the sum of your turns is going to add to 360. If you're driving a triangle, if I'm going this way, I would have to turn my wheels 130, then turn my wheels 80, then turn my wheels 150. So the exterior angle, you can think about your turning angle of a car or a bicycle or whatever. And because every shape is going to end up back where I started, they always sum to 360. So if I have a pentagon, so a 5-sided shape there, my exterior angles have to sum to 360 as well, because if I make 5 turns, I'm going to end up back where I started. So the sum of the exterior angles always adds to 360. And if it's a regular shape, I can find each exterior angle by just doing 360 divided by n. So because the total is 360 and there's n exterior angles, just like there's n interior angles. So for example, if we look at a regular hexagon, so that's a 6-sided shape. So as I drive along, if I keep going, that's where I would head off, but instead I want to turn. How much do I turn? Well, it's 360 divided by n. I'm going to turn 60 degrees. Then my next exterior angle, I'm going to keep going that straight line, but if I want to keep following the shape, I'd have to turn 60. So you can think about exterior as the amount someone's got to turn. Again, your total turns have to add up to 360. So each of those 6 angles is going to be 60 degrees. So that's exterior angles. 360 divided by n in a regular polygon will be any exterior angle. And again, we can use this now to solve problems about missing angles, missing sides, and we can call that what we know about exterior angles. That's all for this recap video. Let me know if you have any questions, and then you'll do the U6A3 homework to solve problems involving both interior and exterior angles. Okay, thanks for watching, and bye for now.